exponential functions are any function where the variable is in the exponent, like this one, 5 to the minus x. Okay? A typical one might be 2 to the x. Okay? 2 to the x looks like that. Y equal 14 to the x looks like that. They all tend to look the same, and they all go through this point, 0, 1. The reason is that any number to the 0th power is equal to 1. So it doesn't matter what the base is, whether it's 2 to the x or 14 to the x, it's still going to go through that point, and then it's going to sharply rise. So exponential functions tend to look like this. Okay? Now, what they gave us was 5 to the minus x. Well, if I was graphing 5 to the x, it would look just like that, and it would go through this point. What's the consequences of that negative sign are a reflection over the y-axis, is what it is.
So does that mean it goes the other way underneath, in the minus direction?
Like that. The red is a reflection over the y-axis. Now, there's two different reflections you can have. If I had y equal minus 5 to the x, that's a vertical reflection. That would look like that. In other words, this is a reflection over the x-axis. This is a reflection over the y-axis, and that's why it looks like the red. You with me? Pretty much the way algebra is taught is they teach you approximately 10 basic elementary functions. And then they teach you translations of those functions. And just about any function you want to talk about is a translation of one of the elementary functions. So when you have something like 5 to the x, the secret is, well, what does 5 to the x look like? Well, excuse me, when you have 5 to the minus x. The secret is determining, well, if I know what 5 to the x looks like, I know that I'm looking at the reflection over the y-axis. Let's leave it at that for a moment, and if we have to get into that more later, I will. There are 6 transformations that can be done. And probably you need to know them. I don't know. I'm trying to remember if we've had to deal with them or not in the past. I can't remember where we had to learn all about the transformations. But maybe we have to now. So, what graph is my red line?
It's got to be the third one.
Either the third or the fourth. It's the third because it's got to go through that point, 0, 1. And the third one goes through that point. Notice, that's 0, 1. Whereas this one has the same shape, but it goes through the point 0, 4. So it's not the fourth one. It's definitely the third one. How do we enter that? Just click on it? Oh, I guess so. More exponential problems. Notice why I say that. It's because the variable is in the exponent.
Mm-hmm.
And that might seem like a subtle thing, but it's not. If I told you that 7 was equal to 2 to the x power, you would not be able to solve that using your calculator. That is an exponential equation. It's not an algebraic one. So I can't use algebra to solve it. Notice the variables in the exponent. Well, same with any of these. What you end up having to use is logarithms to solve it.
So we haven't talked about logarithms.
Well, we've talked a little bit about it, not a lot. When we get to logs, we'll do it. Turns out that this one, you don't need to use logarithms. In other words, they're saying the population as a function of time is 367,000 times the number e to the minus 0.024, and they say, what will the population be in 12 years? So I just have to substitute 12. Now there's no variables over there. You can get that number out of your calculator. Now, does your calculator have an E on it? Does it have a pi? If it has a pi, it probably has an E key.
It has a EE.
That's expected value, probably.
I
All right.
can't see it very well. It could be then that second function.
Well,
Oh yeah, I do have an E.
okay. First of all, do this. It's a little tricky getting this into your calculator. It's really easy to make a mistake. So the way I do it is I multiply 12 times that number, and then I take E to the result. I think that's the same as E to the minus 0.36. So come up with a number, E to the minus 0.36 first. Do you know how to take it to a power?
No.
Well, you basically go E raised, do you have that key on your thing, to the minus 0.36. Do you have this key?
No.
Do you have anything on the calculator you're using that lets you raise stuff to a power? Oh, you know what? Use the keypad. The question is, will this do that? In other words, the keypad lets us raise stuff to a power. So I wonder if I put in nothing but numbers here. Let's try it. 367,123 times E. It does not show an E. I remember we ran into this before and it accepted. No, it did not like my number E. It's got pi over there, but it doesn't have E. Why doesn't it have E? Maybe if I multiply it by E. It doesn't even like the multiple. Oh, it's because I didn't. No. Well, I wonder if it'll take an approximation. Let's try. Times 2. Boy, it doesn't want anything but a number, does it? Well, I can get that on my calculator. Hold on, let me pull my calculator out. not sure what your solution's going to be for this. I wouldn't think you'd want to get another calculator. But you do need the ability to take numbers to exponents. So let's see, if I do 367,000 times E to the minus 0.36. And that's the number we're looking for. And that is even my calculator won't convert that. What is going on here? Hold on. Sorry. If I do E raised to minus 0.36, Control Enter, it just gives me 1 over E to the 0.36. It doesn't convert that to a number. Okay, let's do it the hard way on Wolfram Alpha. I don't know why my calculator's having problems with it, but Wolfram Alpha is something. Are you going to be taking your test online or in person?
Online.
Well, this is probably a site you want to go to, because this is a better calculator. Notice what this calculator is going to let me do. 367,000 times E raised to the minus 0.36. Not only will it give me the answer, but it'll tell me what I put in. And notice that's exactly what I put in. E to the minus 0.36 is the same as 1 over E to the 0.36. And it gives me that answer, 2.56047 times 10 to the 5th, which is 5 zeros. So it should be 256,047. 256,047. 256,047. What am I doing wrong here? How come it doesn't like, 256,000 doesn't like those commas.
So go to explain error.
Well, hold on. Let me look at the problem again, see why I made a mistake here. Population's definitely going down. It doesn't tell you exactly what your error is, huh?
Go to solution.
Okay, it did exactly what I did. Interesting.
Slightly.
Hold on a second. It's a little different. Yeah, let me do this. Figure out why Wolfram Alpha is off. That's the same number. The Wolfram Alpha, did I multiply 12 times that wrong? 12 times 24 is 30. No, it isn't 36. That's my problem.
So 0.288.
12 times 24 is what? 0.288. So that's got to be 288 instead of 36. I just made a mistake in my doing the math on my own. And that gives us 275,163. So the only mistake I made was multiplying 12 by 24 in my head and getting the wrong answer. But even still, you're going to need a way to do exponentials. And if you don't have it on your calculator, then you're going to need to access Wolfram Alpha for these problems. So let me do this. Let me copy and paste this into the chat window and go ahead and click on it. And that'll open it up. Did you click on that?
Yeah, I have it.
And now save it so that you can get back to it.
Yeah, okay.
Okay? And this will allow you to do exponentials. In other words, I could do any exponential I need to do. I'll keep it up so in case we need to do more, which I suspect we will. Okay, back to practice. And next. All right. Notice that this is kind of similar. This is actually quite a bit easier. This is a standard exponential curve, 2 to the x. It's going to look just like all the others I drew.
I think it's must be B, right?
Correct. Let's go forward. You know that because it goes through that point 0, 1.
Mm-hmm.
And that's the only one that looks like that goes through that point. Whoops, I gotta answer it. There, I guess you gotta highlight it. Now, let's talk about this separately here. If I have y equals some number to the x, well, as long as that number is greater than 1, it's going to look like that. If the number is between 0 and 1, it's going to look like this. In other words, if I have y equals 1/2 to the x power, notice that when we start exponentiating fractions, they get smaller. 1/2 squared is 1/4. 1/2 cubed is 1/8. So the curve has to be this one here. It's going down.
Is that a really shallow curve then?
Well, it's the same as my black curve, only it goes from big to little. In other words, it is asymptotic. It goes through this same point, because still any number to the 0th power is still 1. So it goes through that point, and then it gets closer and closer to the x-axis without ever touching it. So it's pretty much an exact reflection over the y-axis of a normal-looking exponential curve. Okay? So if we go back to our problem, we're looking at a number that's less than 1 here. 4/5.
So does that mean it's got to be like D?
Did you say D as in David?
Yeah.
Yep.
Because it looks like it's not. It's
correct. It's going from big to little. The key is it goes through that point 0, 1. That's the key. Because a lot of these go from big to little. A goes, B goes from big to little, but they don't both go through that point. So notice that if you substitute 0 for x, h of x is 1. That's why all of these functions go through the point 0, 1. Let's have you do this one just to make sure you can use Wolfram Alpha. Go to Wolfram Alpha, because you got to have a way to do these. They're obviously going to give you some.
Okay, let me write this problem down first, though.
Okay. So B is going to be 6 to the minus 0.01 times 400, which is the same as 6 to the minus 4th power. Get that on your calculator or on Wolfram Alpha. You know how to do it? You want me to show you? Because I've got Wolfram Alpha up also. I can show you how to put that in there. You type 6, and then the shift above the 6 is that upper arrow key, and 4. That's 6 to the 4th power. And it even gives you the answer before you even finish typing it. It's 1296. Do you get that?
Yeah.
So that is B. What was that again? What was that number?
1,296.
1,296 is B. Notice what B is. B is the fractional part of a battery that's still good. Hold on a minute. Statistics show that the fractional part of a battery that is still good is given by B. Just figured out what B is. It's not 1296. I did the wrong thing. Perhaps you did too. It's B to the minus 4 power. And I got to put it in with parentheses. You see how I'm putting it in? That's how you have to put it in. In other words, I think I got to use the parentheses. I'm not positive I have to, but the answer is 0.00077. In other words, it's really 1 over 6 to the 4th power. That's what it really is. It's 1 over 6 to the 4th power. Okay, so B is 1 over 6 to the 4th power, and that's the fractional part that's still operating. So I should be able to put this as 1 over that big number. What was that number? Do you remember? 12 what?
1296.
So it should be 1 over 1296. Let's see if they like that answer. 1 over 1296. Do I have to use the keypad here? Probably not.
Yeah.
Really? Even though they give it to me as in fractional?
I'll try it.
Yeah, I'll try it. Yeah, they accept it. In other words, as long as they give it to you as a fraction, you don't need to use the keypad. Okay, use your calculator to find f of 0.5. Let me show you how to put this in. Go ahead and try to do it with Wolfram Alpha, and then I'll show you how to do it and make sure yours matches mine.
So hang on, it's
Hold on. Before you give me an answer, make sure it looks just like this. I can just type E to the, and I'm going to put parentheses around it, 0.24 times 0.5. See the way whoops, hold on, that's not right. It's 0.24 raised, excuse me, hold on, I'll get there, times 0.5. Now, do you see why that's correct? On my Wolfram alpha, I've got 1400 times the number E raised, now I forgot my negative sign. I need a negative sign in front of that 2.24, right there. That's the way it's supposed to read. Does yours read that?
yeah, we'll do here in a second.
Okay. Interesting, it took my answer away. So
I got 1,235.49.
1,235?
Yeah.
I got 1,241. Does your thing read exactly the way this reads?
I got 1400E raised, and then parentheses negative 0.25 times 0.5.
It's 0.24.
So 1,241.68.
Correct. Now it says rounded to the nearest hundredth. So what's our answer?
242?
Huh? To the nearest hundredth is that second digit to the right of the decimal place. So my answer is going to be 1,241.69 because the 8 rounds up to a 9. See why?
Mm-hmm.
All right. 1,241.69. Again, you're going to have to figure out, in other words, you're going to have to do an exponential. So we've had 3 straight problems where you're going to have to use Wolfram alpha to figure out what it is. Okay. Now, this one, I'm going to put in, I'll put it in, and then there's the multiplication sign, and it's 3 raised to the, and now here I need parentheses because it's minus x, although in this case it's not x, it's 8, minus 8 divided by 4, and I'm going to put it in just filling everything in like that. Minus, no, I didn't do it right, hold on, minus 8 divided by 4. All right. Do you have yours in like that?
Hang on. I gotta. I've got 4.66.
That's it. Okay. Now, the problem is a little tricky. They say the revenue function is X times price per unit sold, which is P of X. Well, what we just calculated was P of X. So the revenue is X times P of X. Well, X is 8. So I got to multiply this number by 8. Star 8, just like that. Enter, and I get 37.33. And notice that I did not want to round off before. If I'd have rounded off before multiplying by 8, I would have gotten a different answer. In other words, I would have had round-off error. So to avoid round-off error, try to avoid rounding off until you get the final answer. Now, you see why I'm multiplying by 8? Because the revenue function is X times P of X, and what we calculated was P of X. So I got to multiply that by 8. Should be 37.33. But yeah, you got to be careful on these. It's really easy to make the mistake and put in P of 8 as an answer. That's not what we wanted. We wanted R of 8. And R of 8 is 8 times P of 8. And these are all pretty much the same, and so far you haven't needed logs to solve any of them. All we're doing is figuring out how to get a calculator to give us the answer.
So hang on, let me try and do this one.
Okay.
So value of the machine at the end of 2 years, if the original cost was 1,162. So it would be 1,162 times 2 to the power.
Hold on. It's not times 2. It's times 1 minus R. What's 1 minus R?
0.84.
Correct. That's what you're taking to the second power. In other words, T is what is 2. R is 0.16. So the answer we're going to get is 1162 times, I'm doing it over here on Wolfram Alpha, 0.84 raised to the 2 power, like that. See how I typed it in? And it helps if our answer is less than the original cost, because we're dealing with something that's depreciating. Okay, so if we came up with an answer that was greater than 1162, we know we did something wrong.
Sure.
But we appear to have come up with the answer, round to 2 decimal places. What is that?
0.91.
Correct. 819.91. 819.91. All right. There are 3 different equations that are involved when you compound money. Just go through them in case you need any of them. I'm going to go through them real quick. If you're compounding yearly, you take it down to a bank and they say, whatever you start with, a sub 0, I'm going to pay you 1 plus my interest rate, take it to the t power. In other words, if you get 6%, you put in $100, and at the 100 times 1.06, if you leave it in for 5 years, that's what your amount's going to be. Okay?
Mhm.
Continuous compounding is a little different. It's PERT. That's the way I remember it. P times e to the RT, where P is your initial principal, R is the rate, your annual rate, and T is the number of years. So this is actually relatively easy. It's E equals, if you start with 7475, multiply that by e to the r is 0.1, that's 10%, times 10 years. Well, that's pretty easy to do. You don't really need anything but a calculator, because that's times e. In other words, e to the 0.1 times 10 is e to the 1, e to the 1 is e. So go ahead and put that into Wolfram Alpha and give me what the answer rounded off to 2 decimal places is. Should be about 20,000. 21 maybe. No, maybe 19.
Yeah.
What is it?
$20,319.16.
20,319.16. Okay. And remember, you can't use commas on this.
Mm-hmm.
All right. Well, that answers my next question. Let me write all 3 of them, because they've given us 2 of them. If annual compounding, then A is equal to your initial times 1 plus r to the t. If it's more often than annual, let's say monthly, let's say you find a bank that's willing to compound it monthly, then the formula is your initial times 1 plus the annual rate divided by n to the nt, where n is the number of times per year they're compounding it. So if they were compounding it monthly, then n would be 12. If you find a bank that's willing to compound it daily, then n is 365.
Mm-hmm.
Okay? And then finally you have the third type, which is continuous compounding. And that's the one where A equals PERT. Okay? And those are the 3 kinds. And it looks to me like you're going to have to memorize them, because so far they've asked us a question that involves continuous compounding, and they're asking us a question right now that involves more frequent than annual.
Mm-hmm.
So, and I'm sure you're going to have to know the basic one, which is the top one. So
that top one is the original investment multiplied by 1
plus the annual interest rate, if you're
plus the rate,
in decimal. In other words, if you're earning 10% per year, then it's 1 plus 0.1.
And then t is the time, right?
In years.
Okay.
Now, t isn't always in years, but it's probably always going to be in years for the problems you're going to get.
Yeah, or months.
If we were talking about bacteria growing in a petri dish, then T could be in days. In other words, bacteria might grow by 20% per day. And so R would be 0.2, but T would be in days, not years. In other words, the units that go with T are the same units that go with R. So if they give you R as a yearly rate, then T is in years. Now, here, let me get this so I can write it out. We're doing this middle one. Notice they actually give you the formula, so maybe you don't have to memorize. Notice that the formula they gave us was the same as what I wrote here, only they used P instead of A sub 0. P is your original principal always, so it doesn't really matter the letters they use. The fact that they give you the formula is nice. That means that's one less thing you have to memorize.
So would that be 9% divided by 20 years?
Not 20 years. N is the number of times per year they're compounding it. Compounded annually, wow, which means N is 1, which means we're back to formula number 1. I don't know why they would do that to you, but they did it. In other words, they're saying that R is 0.09, okay? But then they say compounded annually. Well, if it's compounded annually, we use that one, not the second one. And notice that they're the same thing if N is 1. In other words, if it's compounded annually, then N is going to be 1. So maybe they're not ever going to give you this first formula and give you strictly the second and third formula. Because I guess it works just fine. You just let N equal 1. Okay, so our amount is going to be 13,500 times, well, 1.09 to the 20th power. So that's the number you need to get off of Wolfram Alpha. 13,500 times 1.09 raised to the 20th power. Here, let me do that while you're doing it. I'll put it in also. 1,3500 times, and I'm just going to use parentheses, 1.09 end paren raised to the 20th. You see how I put it in?
I got 75,659.
Correct. And notice that you get that even before you finish it. It gave me that answer before I hit enter. Now if I hit enter, it'll give it to me again. But now you do have to round that. It's point what? After the decimal.
0.55.
Correct. So 75,659. 75,659.55. And that makes sense. After 20 years, if you're earning 9% a year, you're going to triple your money. More than triple it. What is that? That's like 5 times. Wouldn't you like to be able to earn 9% for 20 years?
Yeah, right. 0.009.
What's that?
Said point.
Oh, yeah. What we're looking at nowadays, yeah. I know.
All right, shall we move on?
Okay. So I need to go back to lesson.
Yeah.
Are we done with 8.3?
Yeah, I think I'm good. I'll just have to take when we're finished.
We finished it?
Yeah.
Okay. Yeah, well, that wasn't bad. It really is more of a calculator. And in other words, as long as you have a calculator that lets you do exponentials, that's all you needed for that whole thing. So we'll go to 8.4 now, logs. See what kind of nice log questions they have. Okay, these are good. I like this. Now, the one thing you need to be able to do with logs is to convert between logarithmic and exponential. In other words, I got exponential expressions and I got logarithmic expressions. And they're the same. If you want to convert log to exponent, you take the number on the far left, 7, you raise it to the power on the far right, 2, and it's equal to the argument. So I get 7 squared equals x. So x is 49. So tell me what this would be. The log base 8 of 64 equals x. Solve that.
So it's 8.
Go ahead. 8 to what?
8.
It's 8 to the x power equals 64. Well, what's x? 2.
It's 8, yeah, it's 8 eighths, right?
8 squared is 64. So if they ask you to evaluate that logarithmic expression, the answer is 2.
Okay.
Okay. Now, this one was actually a little easier because they put the x inside the argument. But the answer, nonetheless, is 49. Okay. What's this one? How would I write this so that I could solve it? Start with the number on the far left.
So 64. Raised to the power of 2?
Minus 1/2. No, raised to the power of minus 1/2 equals x, the argument. Now, what's 64 to the minus 1/2? That's the same as 1 over 64 to the plus 1/2, first of all. And what's 64 to the 1/2 power? That means the square root of 64. In other words, if you put that into your calculator or Wolfram Alpha, if you said 64 to the 1/2, it'll give you 8. So this is 1/8. That's our answer. Now, you can also put that into Wolfram Alpha directly. You don't have to convert it to a positive exponent like I did. I just want to make sure you know that's what it means. In other words, any number to a negative exponent is the same as 1 over that number to a positive exponent. Now, this one I'm probably going to have to use the keypad, right? To enter 1/8. Okay. These are all pretty straightforward once you get the pattern down. So what's the exponential equation for this?
So 4 raised to the 1/2 equals x.
Okay. What's that equal to? You don't really need a calculator for that. Just know that 1/2 is square root.
What? It's 1/2.
It's 2. 4 to the 1/2 power is 2. Make sure you do it on Wolfram Alpha. Do 4 raised to the 0.5.
Yeah, but I just took the square root of 4 is 2, right?
Correct. So that's the answer. Because that's what this means, is the square root of 4.
So in the previous,
That's what it means right there.
but in the prior example, it was 1/8, right?
No, it was minus 1/2. And here's what the previous one was. Okay? So the minus immediately tells us that it's reciprocal. It's this.
Okay.
Okay? And then 64th to the 1/2 power is 8. So that's how I got 1/8.
Mm-hmm.
Whereas this case, it's 4 to the 1/2, which is just 2.
Okay. Those minus signs.
Well, they give, most of my students, they give a lot of problem to, but they shouldn't. Let's just go over that again. Tell me what this is. First translate it to a positive exponent. What is it if I'm going to write it with a positive exponent?
2.
1 over 2 to the third. That's what negative exponents mean. That's it. And that is 1/8 also. Okay. What is 1? No, I won't make it that tricky. What is 3 to the minus 3?
1/3.
Well, let's write it with a positive exponent like that. That's 1/27. In other words, I've got to do that. I've got to take 3 to the third power, which is 27. Now, if I wanted to make it a little harder, what's this? And I need parentheses, because I want that minus 2 to operate on that whole thing. So first of all, how would I write it using a positive exponent?
Uh,
1 over
2.
1/2 to the positive 2.
Okay.
That's what that's equal. Now, what's 1/2 squared equal to?
0.25.
1/4. In other words, 1/2 times 1/2 is 1/4.
Yeah.
And now 1 divided by 1/4, I flip the bottom and multiply, and I get 4. So that's the answer to that problem. 1/2 to the minus 2 is actually equal to 4. So that's all you do with negative exponents, is put a 1 over the number to the positive exponent. It's that straightforward, always. Oh, this is a new one, yeah, okay. So what's my equation, what's my exponential equation going to be here?
9 raised to the negative 2 equals x.
Okay, now rewrite that with a positive exponent.
Is it 1 over 9 raised to the 2?
Yep, which is 1 over 81. That's x. Let me put that in there, and then I've got an 8 o'clock, so I'm going to have to run.
Yeah, no problem.
1 over, what'd I say, 81?
81.
Now help me get out of here again. Let's see. Save and end practice. Save and exit.
Yeah. Just go to cancel out the Hawks learning. That tab.
That's all I have to do. Oh, and then sign out. Okay.
Yeah.
Now I got it. Now I got it figured out. Cancel that before signing out. All right. Darren, I will talk to you next time.
Yeah, I'll talk to you soon.
Okay. Bye-bye.
Thanks, David.